Okay. In this presentation, we're going to cover integrated hearing loop systems. In our previous webinars, we talked about hearing loop systems. We also covered the vPro drivers, which was more in-depth webinar, etc. We talked about assistive listening in the first webinar that you may have taken part in. So I'm just going to start very quickly by covering the principles of hearing loops really quickly. For those who may have missed webinars or may not know, so hearing loops is a technology that is installed in locations, in millions of locations throughout the world. It enables people to use the technology to receive the sound direct to hearing aids, not via any sort of streamers or receivers. The sound can be received direct by hearing aids without latency. Particularly good technology for noisy environments because it isolates and dissipates the surrounding noise, which is typically picked up by hearing aids. So hearing loops improve communication in different environments. Typically, we think of big halls like lecture halls and auditoriums and theaters and places of worship. But actually, this webinar is going to talk about integration into a lot of much smaller applications. So the principles of hearing loop, again, you may have seen it in previous webinar. You have an audio source. I'm connecting the audio source to a hearing loop driver or hearing loop amplifier. It's a clever device that's able to take the sound source in either an analog or digital way, convert it into current and voltage, adjustable. And when current and voltage is driven into a copper loop in an adjustable, careful way, it creates a magnetic field. It creates a cloud in the area of the loop, and that cloud is then able to deliver sounds through the magnetic field that's created. If we look at the structure of a hearing aid in a second, and a hearing aid user can walk into that cloud and receive the sound. When they're in this cloud or this magnetic field, they can receive the sound direct into their hearing aids. I'm going to play a very short video that demonstrates the difference of somebody speaking in the same room, how the sound is heard without a loop, and then switch it onto a microphone that's connected to the loop, and how then the sound sounds through a loop. So it's a very quick demonstration. It's a minute-long video done by one of our own engineers. We're standing in a room. He's talking normally, not through the microphone in the room. There's background noise and reverberation of the sound and echo. But as soon as he switches the mic on and talks through the mic, sound comes through the loop, and there's a notable difference. Hopefully, you can hear my audio. Hopefully you can hear the audio now. So I'm going to play a video and get back to the presentation afterward.
The audio you're hearing now is equivalent to hearing aids set to the M position, and the distance between us is noticeable with the echo within the room. The microphone I'm using now is connected directly to the loop system, and when you switch your hearing aid to the T position, you are now tuned into the hearing loop system, and as you can tell, the quality of sound is far, far better.
So what we could hear in this, hopefully you was able to hear the sound. What we could hear is in the first few seconds he's talking as he would normally, and he then switches the microphone on, and the microphone is then fed through the loop. So let's talk about hearing aids. Human beings have invented hearing aids as a solution for hearing loss. It is a good solution. It does help, and it also does have its limits and constraints. There are typically 5 or 6 popular types of hearing aids: in the canal, in the ear, open fit, behind the ear, behind the ear with an ear mold, and then behind the ear with high amplification, the one on the right. The bigger, as you can see, I mean, it's pretty obvious, the bigger the hearing aid is, the more space there is in the cabinet to put a bigger battery, to put bigger amplifier, to put other features in that space. The smaller it is and the more hidden it is and discrete and it goes totally in the ear, the space is very, very limited. And the hearing aid manufacturers then start to take out components that are not necessary. So typically the bigger hearing aids, I want to say probably the three on the right side would typically have what's called a telecoil. So if we look at the structure of a typical hearing aid, a typical hearing aid has an ear mold and an ear hook, which is the parts that basically lead the sound into the actual ear canal and play the sound in the ear canal. It would have a small boundary microphone. It would have volume control, and it would have a battery compartment, either rechargeable or replaceable, non-rechargeable. That's how a hearing aid typically works. In terms of the telecoil, which is a small coil, a tiny coil that's installed inside the hearing aid, the telecoil can be activated in 3 different ways. It can be activated manually by physically pressing a button, which stops the microphone and starts the reception of the telecoil. It can be activated via an app. So I have an app on my smartphone, and in that app, I can switch things on or off. And so consequently, I can switch the microphone off and the telecoil on. Or it can be automatically through a sensor. So I walk into an area, the hearing aid senses the magnetic field and automatically switches the T-coil on. Essentially, the T-coil senses the magnetic field and then picks up the sound, links to that magnetic field, the cloud, and picks up the sound from it, converts it back, the hearing aid amplifier converts it back into sound and plays it through the ear mold and through the hook. So that's in principle how the hearing aids work with the telecoil and how the telecoil work. Integrated hearing loop systems have a number of keys. There's a lot of similarity to the principles of standard hearing loop that we install in churches and cinemas and classrooms, etc. In terms of the standard, so it is the same standard, the EN 60118-4. This is the standard for the installation of hearing loops, what the installer has to do in order to determine to achieve a certain performance. Achieving a certain performance is very important because that then ensures that me as a user will experience good sound and experience the same performance in every loop system that I'm using. So the frequency bandwidth is still the same between 100 Hertz and 5K. So that covers the frequency, sort of a wide frequency response, particularly for speech. The difference between a one-to-one and integrated hearing loops to the large area hearing loops is the IEC standard allows plus and minus 6 decibel variation. So that means between -6 and +6, if my system complies to that variation, then I'm meeting standard and I can commission my loop. And that measurement is done at 1K over a measured listening area. So the standard specifies 3 measurements across a small area in terms of horizontal and vertical measurements. And it can be equivalent to walking around the room and testing the loop in say 6 different positions across the room. Only in one-to-one systems, it's only a much smaller space, much smaller area. Obviously, the current that requires to achieve 0 decibels is depending on different factors. We have metal, we have EMI and other factors that can impact the required current from the driver. We've been integrating hearing loops for many, many years in a lot of different applications and a lot of locations globally. It enables customers to access sound whenever there is an audible message played. And if you think about it, And you know, audio is played in ATM machines and LED screens and ticket machines and supermarket service checkouts and door entry systems and help points and evacuation system, telephones, elevators, lifts. So in a lot of these applications, there's audio that's being played from a relatively small sound source, and people with hearing aids would struggle to receive this sound. So we have systems and solutions that are integrated into lots of different applications in order to add hearing loop technology. So going into more details, it allows self-service counters, for example, or help points, for example, to have a hearing loop feature added. So if we look at this photo, for example, and the diagram at the bottom, so if I'm adding a small hearing loop, it will create a small sort of magnetic field cloud, and if that's installed in the right height, a hearing aid user will be able to tap into the sound that's coming out of the speaker, even if it's very noisy outside. It might be on a very busy street, a railway station, bus terminal, airport, etc. The sound that will come through this cloud will deliver only the sound source and nothing else, because it comes directly, it's connected to the sound source. Other examples, door entry systems, so it will provide clear audio to the hearing aid users. This particular module in the photo accepts different audio signals. So basically, this is an all-in-one integrated hearing loop system, consists of the driver and the aerial built into this sign. So of course I need to power this driver, and I need to connect the driver to the loop aerial, and I also need to feed the audio into the driver. So the driver needs power and needs audio. The loop needs to be connected to the driver. And these systems have certain configurations in order for us to know what the signal strength and size is. A lot of our integrated systems consist of the IL-A42. Okay, and this is we have about 4 or 5 different varieties of it. This is one of them, a typical IL-42. So the IL-42 is a tiny PCB, as you can see in this photo, probably in the size of a cigarette box, very small and very low profile. And essentially, this is a hearing loop driver. So if I go from the left to the right, I have a 14 volt. This is between 14 and 12 volt power supply. So this can be powered either from an external power supply like our PS55, or it can be powered through the item that you're integrating into. So for example, if you're integrating into an elevator or into a ticket machine, you will take power from somewhere within the ticket machine. And I'm going to show quite a lot of examples of that. The CA10-02 is basically a code for a small wire that we offer, that on one side has the connector that fits into here, and on the other side just have an open wire. And that then enables you to fix this into anything. It's that small, it will fit into anything, and then power it up from a 12 volt supply that's in your machine. So for example, if it's an ATM machine, you would find the power outlet and just hook this wire in. Underneath that wire connection is the hearing loop output. Same as a hearing loop output on a bigger amplifier. So we have an in and an out. Hearing loop wire always goes out of the driver and then circles around and comes back. And on the right side, we have the audio connectors. In this particular model, we have 2 types of audio connectors. One is a 3.5 millimeter connector, the one at the top, and then we have like a Phoenix style green connector with screws at the bottom. So on the right side, I'm feeding the audio into the amplifier. into this amplifier. Okay, on the left side, I'm outputting the loop and I'm getting power in, and that's all there is to it. This is a very, very small PCB, which allows us to integrate it into a lot of applications very easily, but also allows us to create other things with it. So we have created about 4 or 5 different products already, and we are actually working on some other ones as well. And these products essentially are a complete miniature loop system. So this one, for example, the one in the top center, the EL42PB, is an IP-rated box. Inside that box, at the back of it, it's got the driver, and it also has an area, a loop area. You can actually see the back of this here. Okay, so that is the driver pre-connected to a loop area with multiple turns. I think there's about 13 or 12 turns on this wire. So I have a complete loop system inside each one of these units. Okay, the only thing I need to do is to connect them to power and to feed the audio that I want to play through them. Other than that, they're ready to go. So if you buy one of these and you want to hook it up to an ATM machine or a door entry system or a voice evacuation system, whatever it may be, you fix it on the wall and you just feed power and audio into it, and off you go, because it's very predictable in terms of what sound, what cloud, magnetic cloud it's generating. And these are very small systems, remember. So in terms of the magnetic signal, you are talking about maybe a 2 feet by 2 feet field. So this has to be quite close to the head of the user in the right height in order to be effective. So in terms of applications, we are integrating into ticket machines. We're going to look at examples now coming up. We are integrating into ATM machines, self-service, automated checkouts in grocery stores and supermarkets, check-in desks and stations, door entry systems, intercom systems, fire and smoke alarms, car parks or parking lot, lifts and elevators. That's a big category for us. Information kiosks, wayfinding systems, bus, trains, trams, and taxis, waiting areas in specified interaction points. So all of these areas in different products and different configurations are integrated. We offer integrated hearing loop technology too. So I have the next 7 or 8 slides. I've put together a number of case studies that I'd like to go through, just to show you how it's done and show you different interesting, nice examples and talk about them. First example, very popular, is supermarket integration. And all the photos you're going to see in the next sort of 7 or 8 slides are real photos from installation, so they're not made up or touched up, etc. These are real photos. So this is in a big grocery store. The photo on the left shows sort of a basket counter. So if you have 5 or 6 products, you're standing up, you're just scanning quickly the products and moving on. Whereas the one on the right is a bigger self-service checkout. You might come with your cart or your basket with more products, and you're scanning them from left to right. Both of those items have sound. There is sound coming out of them. The sound is important because it gives you indication of pricing, it gives you greeting messages, it gives you other messages, any problems with your card, etc. You have no chance of hearing those messages with standard hearing aids because of the environmental noise. The level of sound that's coming out of this is not very high. The speakers are very small. So obviously everyone on this call knows that the challenges of hearing loops or the cons of hearing loops is metal content, EMI, background noise. We can't install a hearing loop underneath this tray here because it's all stainless steel, obviously. So where the loops are installed, typically in these kind of positions, we are installing a loop aerial behind the screen. So we we would take the screen apart or work with the manufacturer of the screen, and we'll put the aerial behind the screen. Because remember, this is a plastic frame, the screen is glass or plastic. So that's not a problem for the loop. The loop has no impact to anything else here. We always have to be quite creative when we look at integration of hearing loops, but we have all the expertise and products to integrate loops literally everywhere. So for example, here the loop is installed inside the screen, and on those counters, the loop is installed behind that black, the whole black frame, okay? We have to be a little bit careful sometimes with credit card machines like this one, because if the loop is very powerful and it overwhelms the credit card machine, it can cause interference to the credit card machine. So we might sort of go around it with a loop like this, like an L shape. But it's very rare, and you need quite a strong signal. So if I'm integrating behind these screens, there's nothing that disturbs the loop signal, the magnetic signal. It comes through plastic and glass, not a problem. And actually, if you look at the angle of those screens, it actually creates an upwards angle towards the head, so it's absolutely ideal for loops. One thing to remember is signage. If we don't inform people that there is hearing loop integrated here, they will never know. And so in some cases, we work with the actual customer, and they'll put the loop signage on the screen in the software. And then in these examples, we just put the loop stickers, as you can see on both photos, actually. So the customer that's using it, they know that there is a loop, they switch onto the T position, and they can hear the sound that's coming from there. Other examples is customer service desk. So if we go to any store, and it could be sort of a grocery store, it could be clothing or anything else, fashion, whatever it may be, customer service desk is an interaction point. You may return products there, you may purchase product there. Again, a microphone is being the sound source, so we are installing a microphone that picks up the customer service person's voice, and that microphone is fed into the driver and into that little system that is integrated here. And again, that system will produce a very small magnetic field, maybe 2 feet, so it has to be in the right height, in the right angle. It has to be powered internally by something at the other side of the desk. So it's a nice integration. It's one of the other products that was on the previous slide that I showed. This product sandwiches onto it has like 2 plates that sandwich onto something, enable you to basically have a very firm fixing onto something, and it holds the entire system in, the driver and the loop area. So all I've got to do is power it up and connect the sound source. Another good example is wayfinding and tourism applications. So this is a photo that was taken in the UK, a very well-known site where you are walking outdoors and you're visiting different exhibits outdoors. And as you come to an exhibit, you press the button and there's an audible explanation that comes through this speaker. But again, the accessibility laws mandated accessibility. And if you have a hearing aid, you are not going to be able to hear that explanation coming through the speakers. So again, this product is a complete loop system. It's been hooked up to the audio source and the power source that already exists here. All we need is a 12-volt and an audio, and job done. It produces a magnetic field. It's IP rated for outdoor use. And you can hear the audio and walk out to the next exhibitor, maybe 200 or 300 feet away, and you can repeat the same here. So you will need one of these systems for every audio source that you have on every exhibit item. So that's an outdoor application, but it's utilizing the audio source and the power source that's already there. So pretty straightforward installation. Ticket machine, very popular application. We are selling and installing loops in a lot of ticket machines. Remember, commercially, these are low value systems. They don't cost much, but they can run to big quantities when you are finding the right contract and the right application. So this ticket machine, I think I believe this is in Spain. The challenge, if we look at this photo on the top right, the challenge straight away is that all the faceplate is made out of metal, okay? So it's all metallic. It's like aluminum or stainless steel front plate. So I can't put the loop behind it. I can maybe put the loop behind the screen. Yeah. But that screen is pretty small, so I'm not going to get a big enough signal out of it. So what the installer did in this case, you can see it in this photo out here. They actually managed to get the loop aerial out of the frame, and it's fixed in this black conduit or black trunking. Again, it's IP rated and outdoor rated. So there's a black trunking that goes all around the frame of the screen, and that contains the loop aerial. And it's a big size loop, even though the orientation is wrong. So I mean, it's on the wall where it should be in the floor. And it gives a strong signal, at least 3 feet of projection when you're standing in front of it. And the driver, the audio source and power, it's all internal inside the machine. Again, not a problem because the machine already has power, it already has the audio. So I'm just taking a feed from that and find the right place for the loop aerial. So the challenge with this installation was to put the loop aerial outside in a place where it can be effective. This is a very interesting project. This was a 1,000 LED screens, and actually it's an installation we've done ourselves with a manufacturer of LED screens, and these are smart screens. So these are being used in school these days. They don't have the whiteboards and chalks that I used to have when I was a kid. They have smart screens, so that the kid will stand in front of the screen and do presentations and touch the screen and draw things, write things, and the teacher, of course, would as well. So those are interactive smart screens. And obviously there's sound coming out of them, and the law in different countries requires that this is accessible for children and teachers with hearing loss. So what we've done in this case, we took the screen apart. The manufacturer sent us the screen. We took the screen apart, so we separated it. We took the back of the screen off. You'll see it in the next slide. In order to first and foremost find a place for the loop, see where we can put the loop inside that screen, where we can put a loop aerial. And we discovered that the back of the glass, the back of the screen, is essentially has an empty frame that we could use. So we used the ribbon tape. You can see it at the bottom left. This is a multi-turn copper tape that has probably about nine very very thin copper wires in it, and it comes as a format as a tape. So we were able to stick it on with a strong double-sided tape at the back inside of the screen. So when you look at the TV, when you look at the screen from the outside, you do not see it. It's completely invisible. And this was pretty big size as well. So when it comes to the loop signal, it delivered a very strong loop signal, over 3 feet in front of the screen. You was able to receive the sound very, very clearly as well, because of the size of the loop and the number of turns. Remember, you can't put it behind metal or stainless steel. It has to be behind glass, stone, wood, plastic, anything like that. This project was all about finding the right location for the loop first, testing it, and then the rest was pretty easy, because the rest was just the integration of the small driver, connecting the loop to it, and then powering it up from the internal connector in the screen and then feeding the audio from one of the speakers, literally. So that was an interesting product. It was a high quantity, and the manufacturer basically implemented that loop into all of their screens. So it's a nice ongoing sort of project, because it's required by law to be in all schools and universities, colleges, etc., in that particular country. So the way it looked as a whole, if I took this picture from looking at the open screen, the screen is facing down on the floor, and I'm looking from a bird view. So I have number 4 is my loop driver. It's just fixed into the screen. Yeah. Number 1 is the induction cable. Here is the cable that runs and connects to the ribbon tape. So that's the loop feeder cable, if you like. Number 2 is the power connector. So we have the power connector connected to the PCB of the unit itself, where the number 2 is. And number 3 is the audio connector. So we were able to hook the audio from the audio module here of the screen itself. And so that completes the entire installation. I can now make sure it works, screw the back cover back on, and you never know the loop system is installed inside this unit. Again, then you have to think of signage or how to mark it and let people know that there's a loop system installed. There isn't an adjustment to this system as you have in a large area loop. So it's obviously you're going to hear a little bit, you're going to hear louder if you are sticking your head right by the screen, and as you go out, the sound level reduces. But it was more than compliant with the IEC standard, because the IEC standard tells you to measure in 3 locations and 3 heights, in average of 1.45 meters, and it met the standards without a problem. It is different than fixed loops, integrated loops, because ultimately I can move around. I'm standing in front of an ATM machine or a checkout desk in the supermarket. I can stand a feet away from it, or 2 feet, or 3 or 4 feet, and I can move around. But it doesn't mean that I can't measure it according to the IEC requirement and commission the system. So finally, I want to go into sort of a product and the hardware a little bit. I mentioned the A42, that little PCB so far. We also have other options and bigger options that are just as good or maybe even better. The HLD5 is a dual output hearing loop driver. It is one of our oldest products, but for integration purposes, it is excellent because it has a 100-volt line in. So that's absolutely ideal for public announcements, etc. And it has a flexible dual output option. So with dipsticks, you can make it a phased array driver. It's got a phase shifter, or you can make it a perimeter driver as well. It is, however, bigger in terms of its size. It also costs more, but it is excellent for sort of medium-sized integrations. For example, elevators, lifts, carriage platforms, small waiting rooms, maybe in hotels or in railway stations where you have, something like 10 by 10 feet or 6 by 6 feet, just somewhere where people stand and need to hear announcements. Front-facing floor spaces in front of LED screens, etc., and so on. So it's a single or a dual output. It delivers 7 volts and 3 amps. And everything's adjustable here. And finally, I want to introduce 2 new products that we will be launching very soon. If you visited ISE at the beginning of this year, you may have seen a prototype of it. So actually, we're going to have 2 models. The first model is called ID7. I'm sorry, ID6, and that's the base. That's a more basic model, the one you see in this picture. So despite the compact size and profile of it, it is a Class D, very efficient driver, so it doesn't require any sort of heat dissipation or ventilation, etc. It has a high frequency compensation adjustment, a loop drive adjustment. It's got a 100-volt line in, which is also adjustable. It's got mute. There's a line of LED status lights that tells you whether you've got clipping or power on, power off, and other indications. And maybe the most interesting thing is you can power it from a range of between 12 and 24 volt. So if you're using a 12-volt power supply, you will get approximately 7 volt and 5 amps out of it. But if you're using a 24-volt power supply, so for example, if you're installing in an elevator, the elevator gives you a 24-volt power supply, you can then achieve a much higher power, even higher than our V15 drivers. So you can exceed 7 volt and exceed 5 amps with it. So in terms of power and performance, these drivers can perform better or more advanced than our V series drivers, which is pretty incredible. The ID7 model is the more advanced machine, is going to replace the HLD5 that I showed you a couple of slides ago. So the HLD5 is an older product coming to the end of its life. It's going to be replaced with this. The ID7 brings on board additional features. So now you have mic line input and 100-volt line in. You have a phantom power connection, adjustable as well. You have a battery backup port option, very important for elevators, because if you're installing loop in an elevator, they're going to ask you for a battery backup, and it's also often specified. So the battery backup port here allows you to either connect it to the battery backup of the elevator or the lift, or to use our own battery pack that we're going to supply with this product. And that means that in case the lift or the elevator has no power and gets stuck, the loop would work for approximately 6 or 7 hours. Also, the ID7 has flexible dual output, same as the HLD5. You can do a phase array with a phase shifter or a perimeter with it. So this is a much more advanced machine than the ID6. In terms of a side profile, they're going to look like this. So they're very low line, very slim line profile, intended for installation. So you can see this is intended to be stuck or drilled onto a surface, fixed onto a surface. And it's not something that is intended into an installation in a rack. It's very, very small as well. So if I put these products side by side, the ID6 basic model is on the right. You can see that the ID7 has more connections. It's got the phantom power microphone adjustment, and it has a line of dipsticks here that enables me to transform it from a phased array to a perimeter and vice versa, and also adjust other things through this. And it also has another port here for battery backup. So the ID7 on the left has a lot more additional features. But both of these are drivers that are essentially designed specifically for integration of loop technology, and they're coming out very soon. I think it pretty much wraps up my presentation today. Again, important for us to say that, you know, don't think that large area loops is everything. These commercially, these opportunities are as important and as commercially attractive. They're relatively more simple to implement as well. So if there's any questions, I will be happy to answer. And also James is on the call for anything more advanced, he will be able to answer as well. So questions, please. Nothing, okay. So that was either very clear or everyone fell asleep. Hopefully it's the first.
Hey, Rand,
Yes, Sharon.
I just had a question about thanks for the presentation. And it was had some nice pictures, but I was just wondering if you could do some videos showing some actual installation of some of these systems.
I have to check if there is anything already on our YouTube channel. If not, certainly a good idea. Definitely something we.
You know, like for example, putting a hearing loop in the LCD TV screen.
Yeah. No, absolutely. I will definitely keep this in mind, and I'll check what we have currently on our channel. There may be something there. I'm not sure.
Okay, thanks.
Thank you. Okay, so as I mentioned, we've recorded the call and we will publish it on our YouTube channel. It normally takes a couple of weeks for it to be accepted by YouTube. So if you look at the YouTube channel in a couple of weeks, hopefully it will be there. So I'd like to thank you, James, for helping out with this and with the recording, and thanks everyone for joining. We do have another webinar next Friday, same time next week. James will do this one, and it's about fault finding in hearing loops. So if you are installing hearing loops in larger areas, large venues, etc., I think it's a very important webinar and probably a very interesting one as well next week. So thanks again, and wishing everyone a good weekend.